Section 3.3, exercise 18, and we're given a function f of x equals x squared plus 6x plus 10, and we're applying the first derivative test. So they want us to find the critical numbers. Okay, well, so I need to take the derivative. Derivative of x squared is 2x, derivative of 6x is 6, and derivative of 10 is 0. And I need to set that equal to 0 and solve for x. So 2x equals -6. X is -3. Okay, so there's my only critical number, is x equals -3. And the derivative is defined everywhere, so that's not an issue. Then part B says find the open intervals on which the function is increasing or decreasing. Okay, so the question is, is it increasing or decreasing on the left or the right and so forth? Well, so, at this point, here's -3. And so I just need to pick something over here, say -5. And if I look at f prime of -5, I get, what, 2 times -5 plus 6. And that's -4. And so, here's where things separate, is at x equal -3. But over here we have f prime of x is less than 0. And then if I look over here, probably 0 is the easiest thing. And when I put that in, I see that, f prime of 0 equals 6, which is greater than 0. So over on this side, f prime of x is greater than 0. So my intervals for increasing, I guess that's over here on the left, or right, sorry, increasing, that goes from -3 to infinity, and decreasing goes from -infinity up to -3. So there are the open intervals for increasing and decreasing. C, it says apply the first derivative test. So C, well, actually I'm going to go back up here a little bit and just kind of go, I've got -3 there, and it says the derivative is negative. Oh, okay, that's coming down like that. Then the derivative positive, it's going like that. And so what I see is a relative minimum. Okay, so we've got relative minimum. And then D, it says, hey, go look at the graph and make sure you've got this right. And so I did that. I went ahead and went to Desmos here, and well, that's interesting how it kind of, well, let's see if I can't seem to move the graph all of a sudden. Let's see, I can move it this way, I suppose. Oh, well, that's interesting. So I poked on it there. Okay, I got it going now. Anyway, so here well, if I come in far enough, we can see, whoops, the derivative, oh yeah, I can't draw this way, but the derivative is 0 right there at -3, 1, so -3. And it is indeed a relative minimum. And as we look at I plotted the derivative as well here. And that's the blue line, and so what we see is that, again, right there, the derivative had a value of 0. I don't know. I can't really touch anything and keep it there. But so the value of the derivative is 0 at -3, which is what we thought, and it's positive to the right and negative to the left. We look at our function, and it's decreasing on the left and increasing on the right of -3. And so, yeah, we did it. Yay. Okay, so there's number 18.